Hello guys, and welcome to another one. On this one, we're doing question 3 of June 2024, grade 12. And this one says, the Curiosity rover was dropped from 125 kilometers above the surface of Mars. The mass of Curiosity rover is 899 kg, and the mass of Mars is 6,42 times 10 to the power of 23 kg. The radius of the Mars is 53.25% that of Earth. And then the first question says, state Newton's law of universal gravitation in words. The way in which you state this law is to say that, we can use the formula by the way. We know that the formula for Newton's law of universal gravitation is F is equal to G m1 m2 divided by r squared. How do we state? We will say that each body in the universe will attract every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. That's how we state it. So we say each body in the universe will attract every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square distance between their centers, the square distance between their centers. That's how you state the law. Guys, I can't write it down. By now you know I don't write definitions. You have to have them in your brain. Let's move on to 3.2. 3.2 says, calculate the weight of the Curiosity. They want weight, and we have to remember that weight is calculated by using the formula W is equal to mg. We multiply the mass and the gravitational acceleration. What is the Curiosity? The Curiosity is this object here, right? This is the Curiosity, and it weighs 800, or rather it has a mass. I have not found the weight yet. It has a mass of 899. So I'm going to take that mass, 899. By now we know that G is going to be constant, which is 9,8. We'll say 899 multiplied by 9,8, and the answer we are going to get is, if we punch this on the calculator, it's going to be 8,810,2 newtons. And this is going to be our answer for 3.2. Let's go to 3.3. For 3.3, they are saying, calculate the gravitational acceleration on Mars. Calculate the gravitational acceleration on Mars. Guys, if they want you to find the gravitational acceleration on Mars, the formula you use is G is equal to m. In fact, I should start with, it's G is equal to capital letter G m over r squared. In this case, we are dealing with planet Mars, so the information we will use is planet Mars. This formula, by the way, can also have D here instead of R. Please be aware of that. And when we want this gravitational acceleration, we remember that G is a constant. I'm just gonna I think I remember that value, the constant, but I forgot it, guys. Let's go just check on our constants. Okay, guys, so this is our G. It is the universal gravitational constant. There it is. So we are going to start by substituting it. It's going to be 6,67 times 10 to the power of negative 11 multiplied by m. This capital letter M is the mass of Mars. It's the mass of Mars. So it's going to be 6,42 times 10 to the power of 23. Okay, then we will divide. What about our radius? What we are told, guys, about the radius, and it's always important to go back to the statement. They said that the radius of Mars is 53%, or rather 53.25% that of Earth. So we need to go back and remember that the radius of the mass the radius of Earth is actually a constant. Here it is. Do you see it? It's a constant. So what we can do is to take this radius. It's 6,38. I'm going to take that radius and say 6,38 times 10 to the power of 6 multiplied by the percentage, which is 50. What is it? Is it 53? It's 53,25%. Or another person can see 6,38 times 10 to the power of 6 times 53,25 divided by 100, because they said the mass of Mars is 53,25% that of the radius of the Earth. Yeah, that's what they said. It's radius, my bad. So we will multiply this way, and this has to be squared. Please guys, don't forget to square. All right, and this is what we have now. And if we punch on the calculator, put all of this on the calculator, the answer that we are going to get is 3,71 meters per second squared. Remember, we are looking for gravitational acceleration. I hope guys you see how this one is supposed to be tackled. Okay, there we go. Now we move on to the next question. The next question says, would the mass of the Curiosity be different on Mars than on Earth? Choose from yes or no and give a reason for the answer. Guys, let's make an example. I'm a skinny guy. So let's say as a skinny guy, I go to planet Mars. Do you think when I get there, I'm going to be overweight, or I'm just going to suddenly gain a couple of kilograms in terms of my weight? The answer is no. So me moving from planet Earth to another planet, it's similar to the people who work at NASA, the ones that tend to go to space. When they go to space, they go there having the same weight, and they go there having the same mass. So what's going to happen? Yeah, let's in fact talk about mass. Let's not talk about weight. That's a story for another day. They go there having the same mass or mass. Guys, English is not my forte. They go there having the same mass. And if they come back, they are going to come back the same. Nothing is going to change. Are we clear on that? So the answer is basically no. The mass does not change. Okay, the mass of the Curiosity should be the same, irrespective of where the planet is. You are going to go there with the same mass and come back with the same mass. Nothing is going to change. Why? Because the reason is that mass has to be the same in both planets. It doesn't depend on the planet which you are in. That's basically the reason. Mass is not affected by the type of planet you are in. Are we clear? And we also have to understand the definition of mass, and the definition of mass is that it is the matter of an object, right? Or rather, it is the matter an object is made up of, and that doesn't rely on where that object is positioned. As long as it's there, it will remain like that. I will clear on that. That's how we answer. But the simple answer is that mass does not depend on the planet, so it remains the same regardless of where you are. Okay, that is it for this video, guys. I hope you enjoyed it, and please hit me with a like, guys. You can share the video with your friends, and if you have not subscribed, I never say this a lot, but please do subscribe. See you on the next video. Bye bye.